All right, I forgot to record the answers, so homework questions. There was a question on 17, pause it if you want to see it. A question on 51, pause it if you want to see it. Our evens, 2, 8, 26. Let me get 26. Pause whenever you need to. Okay, and we're done. All right, cool kids. Here vi go. Section 2.6, good news. What's the good news? What's not due tomorrow? Woo! Now, hold on. You know me, don't you? So does that mean you have no pre-calculus homework tonight?
No, that means you start on it.
What is your honors pre-calculus homework for tonight? Thank you. My three. And my others who didn't say it, that doesn't mean that you're not still held accountable for it. So, you heard it. Homework tonight is start. Yeah? Yeah. All right, you guys are new section, new side. You guys are going, new section, new side. How'd your weekend go, guys? Did we survive? Who actually got at least 5 minutes of rest? That's it? Uh-oh. Not even 5 minutes? So no Netflix, huh? No TV shows? Who took the SAT Saturday? Oh, just one?
Headache for the rest of the day.
You're surprised. What is that, guys?
It's just so
It's a
long.
lot, yeah, it's long. You only get like one snack break.
And I had a football game the night before, so we napped at 30.
Wake up early. Poor kid. Don't worry, you guys will experience it soon if you haven't yet. Number 26. Rational functions. And inside rational, I want you to underline ratio.
Oh.
We talked about rationals this morning. Rational numbers. Yeah, like 2 minutes ago. We talked about rational numbers. Remember your rational? No, it wasn't in chapter. Ratio. Hold on, Mr. Crocker. Ratio. Why did I underline ratio if you guys are looking at the rational function and you see f of x over g of x? Why did I underline ratio?
The ratio between
A ratio between the fractions. Like Sean's saying. He's over there. I don't know. So, I don't want to call it r of x though. I just call it h of x. We'll just name it something else. So if we have a function, and if it has a top and it has a bottom, and not just a top and a bottom, but a top with a variable and a bottom with a variable, we call it a rational function. A rational function. Now, the very first thing I put after the general form is domain, because as soon as we see a ratio with variables, top and or bottom, well, top and bottom, I should say, we have to be careful that whoever is in the bottom, and I'm calling him g of x because that's how I labeled it up above, whatever the denominator is cannot equal 0, domain problem from chapter 1, right?
Uh-huh.
Mm-hmm. The denominator, whoever he is, cannot be 0. And wherever the bottom is 0, the function, the entire thing, has a domain problem. But we haven't really described what that domain problem is. Now, just looking at this function down below. Looking at this function down below. Question. If I was just to ask you for the domain, what would you need to do? Set x plus 2, make it not equal to 0, and solve. And hopefully, fairly quickly, you would get x cannot equal -2, right? And that's what we would put down here in the domain. X cannot equal -2. If you want to be super snazzy, and practice your interval notation, you would go from negative infinity to -2 and say, nuh-uh, not you, and then you could go from -2 to infinity and still, once again, tell -2 no, as indicated by the parentheses, not brackets. But domain, x cannot equal -2. Now what does that mean? In context of this section, that means, a little double arrow in math means this implies that there is a discontinuity at, okay. Snazzy way of putting it. There's a discontinuity at x equals -2. That means your function is going from x values like -1 and 0 and 1, but at 2, it's like, tapping out of that. And then it keeps going. So you're like drawing, uh-oh, something happens, and you pick up your pencil, and then you come back in right after 2. Now question, what's right before 2? Oh, sorry. What's right before -2? Hard question, especially since I didn't realize it was a -2. Before, on the left, think -2, who's before him?
-3.
-3, but no.
-2. Wait.
Oh, you were on the right side. Yeah, -2.00000, yeah. -2.00001, Luca and Sean. And then Cosette, you're giving me the other side.
Yeah, I'm sorry.
And the other side would
I was
be
like, wait.
-1 point, and technically I shouldn't stop, right? So hold on, a few of you guys are like, what's right before? -3, and that's hard in and of itself, and then what's after -1, but you're wrong, remember there's all kinds of numbers. So this discontinuity is gonna be very, 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 very quick. Do you guys remember what kinds of discontinuities happen in denominators? There are 2. What could be happening in the graph that you go, and then keep going? A hole is one,
Asymptotes?
or vertical asymptote. So either, poor Luke, give him a pat in the back. Not messing with his finger. So going, hole, keep going, right? Or going, and then it like zips up, and then you have to do something down here, and then you have to break the graph. So either it's a vertical asymptote or a hole. How do we know which one? Let's figure it out. Wrong way. Let's figure it out. Who's who and when do they happen? Who's who and when do they happen? I want you guys to go ahead and take these notes. Once you're done or in the midst of it, when you get to an example, I want you to figure out what's the domain. That's all I'm asking for right now. What's the domain? Then skip a couple lines and do the next one. What's the domain? Skip a couple lines and we're done. So take your time. Write down each function or each part of notes. Write down the example. And ask yourself, what's the domain of the first example, then keep going. What's the domain of the second example, then keep going. What's the domain? What did you guys get for the domain of the first one?
X equal 1, -1.
Yes, but what was my bad in making the problem? This says it's a function of who, and all I see is, okay, so hold on, let's make this better. I did want to give you experience with other variables than x. Let me change that to a t. So now, what's the proper way of writing the domain?
X cannot equal.
I know, I messed you up with the x. T cannot equal -1. Let's just keep it simple. Let's not go to intervals. Let's just say t cannot be -1. How do we find it? T plus 1 can't equal 0. Subtract the 1. T can't equal -1. Man, this page is just a mess. We should sue. Except I made it, so don't sue. Okay, so can be factored out. Be frivolous. Okay, so what do I mean by can be factored out? I look at it and I found a discontinuity. T can't equal -1. It's not out, it's in, it's right there. It doesn't say it is factored out, it says it can be. Kristen, what do you see?
Well, I was just wondering, you took, was that for the t squared minus 1, or was that t opposite of t plus 1?
Opposite of t plus 1.
Okay.
Because it's from the bottom, but you're right. In this one, wait, what'd she notice? What does -1 do to the top and the bottom? It makes both equal 0. Just a quick hint, wholes will always make both equal 0. And there's actually a super snazzy form for that. It's called 0/0. If I plug in, if I test f of -1, I would get 0/0. And this actually is a snazzy name called indeterminate form. I might talk about it in a page or two. We might be jumping the gun. But if you plug in a discontinuity and get 0/0, it's going to be a hole. However, what do I mean by the whole snazzy it can be factored out thing? What happens up top? It's a difference of squares. What does that 0/0 indicate? They have a shared factor. I can remove removable discontinuity. I can remove the discontinuity. I just have to keep the meaning of the original function, I just have to state that extra restricted domain. Does that make sense?
Mm-hmm.
You've seen that a little bit. But what's going on with this one down here? What you did is his discontinuity. What's his domain? X cannot equal
0.
the bottom can't be 0, so x can't be -2. What happens when we plug in -2? 7 plus -4, all over 2 minus 2. 3/0? Is that a whole? Wait, is that a whole? It's actually a snazzy name, infinite form. We'll talk more about tomorrow. But question, can you factor and cancel any? No. That's a vertical asymptote. Cool, kids, I'll see you tomorrow. Okay, perfect. Thanks a lot. Bye, guys.
Miss G,
Sorry, Ers.
I forgot, where do we get the form for
Which one?
tutoring someone?